So how are you today?
I am doing very, very good. I am reconfiguring some of the lab stuff, so I am very curious. Kind of like yesterday we did have some real strange issues. I got a little bit more familiar with dump. I did a little bit of the practice on that one, and once that is layer two troubleshooting. Once I'm comfortable with that, and then I will go further into layer three. But I wanted to set up a decent lab, and that way um, I'll have more knowledge of where it's supposed to, what is the result is supposed to be when I make some changes. So, of course.
Okay.
And one small request: if you said you were recording this, right? I mean, if you have it, just anytime, if you could, if you don't mind sharing it.
Yeah. What I will do, I have those recording,
Yeah,
but the format is, it's not that good. So I have to convert it into the good format.
yeah, no rush at all.
So
Anytime.
once we are done with the training,
Uh huh.
I'll do that,
Yeah,
and
no
I
rush.
will send you all the.
No
I will
problem.
attach it to the Dropbox, and you can take it from there.
Yeah, and no rush at all. For me, it's more about learning is more important, and so no worries at all.
Okay. Let me share my screen.
All right.
And you have any question from last 2 days studies?
Right now, no, I don't have, but I may have more questions as we go down the road. Right now, I because of 'cause it's only been a day, so I don't think I haven't and worked. Have not worked much on the lab yet. So, but as soon as I start breaking things, I will have more and more questions.
Okay. Are you able to see my screen?
Yes, I am.
So far, this is what we have covered.
Yes.
Introduction to checkpoint, deployment platform,
Yeah.
security policies, monitoring and the connections,
Yeah.
right?
Yeah.
Now, today we are going to cover network address translation,
Okay.
identity awareness, using smart update if
Okay.
time permits.
Hmm.
And then next week we'll be covering all these things.
Oh, nice.
Okay,
IPS, VPN. Nice.
right. So you're sure you're so far you don't have any question, right?
Right now, it's I was spending most of the time setting up a small lab,
Mm-hmm.
so I think of setting up a router and getting it to work was my kind of took away most of my time from yesterday. So no problem. I probably will have as we go, but today I'm okay.
Yeah, and again, I'm saying whenever you feel like you have any questions,
Mm-hmm.
just ping me or
Yep.
WhatsApp,
Yep.
whatever it is. Okay, it's
Okay.
not like that during the trainings. After the training, whenever
Yeah.
you stuck somewhere, let me know.
No problem.
I'll
Definitely.
try to guide you,
Yeah.
right?
Yeah.
Okay. So today we will start with the NAT.
Okay.
So what you know about the NAT?
Nat, this is what I think. So let's assume that in the picture you have a router, or this could be a router or a firewall. So
Mm-hmm.
what it is it takes IP. Oops, what happened? Mm, Okay, okay.
No.
It takes the internal IP of
Mm-hmm.
one side, and when it goes outside, so let's say the internal IP is 192 range, but
Mm-hmm.
when it goes to the internet, that IP will change to an external IP. And so what the router firewall will do is it will change either the port number, well, mostly it's the IP. It will change the IP to an external IP. And so the router will, or the firewall will take the responsibility of converting the internal one-to-one mapping, basically. Uh, so that is netting.
Okay. So what you said, I'll just drawing here.
Mm-hmm.
So we'll relate that.
Yep.
This is what you said. This having some IP address,
Mm-hmm.
say 10.1.1.1.
Correct.
It will go here. Firewall do the netting.
Uh-huh.
It will get the some public IP address,
Okay.
and from there it will go to the outside world.
Outside world. So outside world will not know anything about the 10 address, but it will only know about the 192. But the firewall will keep a track of when the reply comes. It knows that to send the traffic back to 10 network.
Okay, based on our studies so far,
Yep.
when the reply come, how the
Uh-huh.
firewall will know this connection is there?
The table, the connection table,
Yes,
state table, kernel table. Okay.
kernel or state table.
Yep. Yep.
Okay, that means you know now how it works,
Yep. Yep.
right?
Yep.
Great. So now we in a checkpoint world, uh, we have two types of NAT settings.
Mm-hmm.
I know you have the understanding on the NAT.
Mm-hmm.
Okay, that's why I'm not covering the basics.
Mm-hmm.
But let's go ahead into the what checkpoint offer in terms of the NAT.
Mm-hmm.
So number one, they say something called hide NAT.
Mm-hmm.
They again something say static NAT,
Mm-hmm.
and they also call something. What happened?
Mm, hide
Yeah,
static. Manual net, maybe.
yeah.
Okay.
My brain is not typing. That's why. Okay, the
Okay.
third one is manual
Manual
NAT.
net. Okay.
Okay. Uh, we have the private IP range, those who no not travel to the outside world.
Yeah. 10 and
Specifically,
172 and 192. Class A.
yeah. So class A, we have 10.0.0.0
Mm-hmm.
to 10.255,
Mm-hmm.
255, 255. Like that, class B
Mm-hmm.
starts 172, 16,
16.0.
0.0
The
to
172, 31, I
192.
think.
Yep,
255.
255 and 255.
Mm-hmm.
Class C
And
is 192,
192, 168.
168,
0.0.
0.0, 192,
Uh-huh.
168, and 255,
Not
255.
255. Okay.
Yeah. And there is something called Bagon's IP address. Bagon IPs. You
Never
heard
heard.
about this term?
No, never heard.
Search on this. So these
Uh-huh.
IP address are the public IP address,
Uh-huh.
but they never travel, or they like this network service provider.
Uh-huh.
They recommended that this IP address should never travel to the outside world.
Oh,
Yeah. So just search this term, you will come to know. I just
okay.
want to tell you when
Okay.
you going to apply the NAT, there
Uh-huh.
is some network range, I think, which is 128 something something,
Uh-huh.
which not or not supposed to be configured for the NAT.
Okay.
If you configure this for NAT, it will work, but
Mm-hmm.
this network generally, very tempted to the hacking or
Ah,
some kind of
okay.
malicious activities.
Okay.
So just for the information.
Okay.
Okay.
So it's 198.
Yeah.
198. Okay.
Just see that, I mean, Google search the term Bagon's IP address. It will
Mm-hmm.
give the IP address range.
Okay.
Okay. So this is how the NAT works. Okay.
Mm-hmm. Mm-hmm.
Let me. So this diagram is explaining everything like how the NATing works in checkpoint firewall and
Uh-huh.
in some sort of the other vendors also.
Uh-huh.
So consider
Uh-huh.
you have some PC
Mm-hmm.
internally. He wanted to go to the outside world.
Mm-hmm.
Okay, how usually it goes without NATing? It directly, if we assign some public IP to it, say 100.1.1.1 for example, it will
Mm-hmm.
directly go to the outside world. Okay,
Mm-hmm. Mm-hmm.
we have a limitation on this public IP address, and if we are assigning this public IP address to each and every machine, it
Mm-hmm.
will be more costly, and you will be, having, this, complete loss
Mm-hmm.
because you are exposing everything to the outside world, and the major thing is cost.
Mm-hmm.
Okay, so we are not doing this arrangement. What we do private IP address. We natted that to the public IP address,
Mm-hmm.
and then it goes outside world.
Mm-hmm.
But again, you natting that each and every private IP address to one, and one to one
Mm-hmm.
NATing. For
Mm-hmm.
example, you
Mm-hmm.
have say n private IP address and you're
Mm-hmm.
NATing to the n public IP address.
Mm-hmm.
Again, this is costly because you're doing same thing what we are referring here. So
Mm-hmm.
all the public IP address you're utilizing for the private IP address only. It provide you better security,
Mm-hmm.
but it is again a costly solution, right?
Mm-hmm. With one to one, you run out of addresses.
Right. To get rid of these things
Uh-huh.
in NATing world, they introduce in a checkpoint terminology we call it hide NAT,
Uh-huh.
and in other firewall terminology we call it as a dynamic NAT.
Okay.
Okay,
Okay.
what in this happens? It act like many to one mapping voice.
Okay.
What that means?
Uh-huh.
You have a many IP address
Uh-huh.
in your internal network,
Uh-huh.
okay, but it will go to the outside world using a single IP address.
Okay. So maybe more than likely it's maybe a port maybe changed.
Yes.
Okay.
So
Got
yeah. So only one IP address. For example, this IP address is you know going outside, but the packets are from this multiple IP addresses.
it.
Okay. So these
Oh.
are the private and these are the public,
Uh-huh.
and then goes to the outside world.
Got it.
Okay. And how the return packet works here? Okay.
Uh-huh.
So as you said, every PC has a simple, say, different IP address and is referring only one IP address, but
Mm-hmm.
there has to be some distinction.
Mm-hmm.
So that distinction will happen using port. Okay. So
Mm-hmm.
in hide NAT or in a dynamic NAT, okay,
Mm-hmm.
it always changes the port. Okay.
Mm-hmm.
So whenever we talks about the hide NAT,
Mm-hmm.
remember we're talking about the port change.
Mm. Okay.
The
INET.
area where the port not changed,
Yeah.
if you have a requirement where you have to have the
One
port
to one.
to be remaining same,
Uh-huh.
you can't use HideNet there. So
Correct.
that is
That's
the, not
static
the
net.
option for that.
Got it.
Okay. So let me clear the screen. Where is my mouse? Now let's see how the packet is goes in and out. I mean, how
Uh,
the packet replies, comes, and how the original packet goes to the outside world, and what are the things it takes with it, and
mm-hmm.
what are the interception points comes under the firewall.
Mm-hmm.
So when you troubleshoot the NATing,
Mm-hmm.
okay, how you come to know whether NAT is happening,
Mm-hmm.
or how you can point it out those things based on the kernel parameters. So let's see
Mm-hmm.
that. So consider this is your original packet. Okay,
Mhm. Mhm.
you wanted to go to the destination
Mhm.
192
Mhm.
9.100.10. Okay,
Mhm. Yep.
and you are browsing over HTTP.
Mhm.
Okay,
For
or a
for
port 80.
80. Mhm.
Okay, and this is your source machine. So consider
Mhm.
this machine is having this IP address
Mhm.
10.1.1.101, and you
Mhm.
wanted to go to the outside world.
Mhm.
So what we have done here, we applied the hide net. Okay,
Mhm. Mhm.
consider we have applied the hide net. I will show you how to apply that, but for
Mhm.
now, just
Mhm.
consider we have applied the hide net. Okay.
Mhm. Mhm.
Now, as I said, hide net always use some port. You know,
Mhm. Mhm.
it changes those port.
Mhm.
You know, uh, I mean, refer those ports for the returning traffic. So
Mhm.
he randomly assign one port,
Mhm.
1305.
Yeah.
Okay. Now this packet is initiated from this machine and it
Mhm.
hit to this firewall.
Mhm.
As soon as this packet hits to this firewall, you
Mhm.
will see I.
That's
So
internet. Internet.
that means the packet is hit to your firewall.
Yeah.
Okay. After this, the routing will perform.
Mhm.
So now you are going from your internal interface
Mhm.
to the external interface because your
Mhm.
public IP address will be always on the external interface.
Mhm.
So you should have to have this natting in place. Okay.
Mhm. Mhm.
So the natting happens, and once that happens, you will see this big eye.
Mhm.
Remember yesterday we run AWD monitor command.
Mhm. Yeah.
You saw small eye,
Yeah. But he
but
never
you
saw.
was not seeing big eye.
Yeah.
So think in this way why you are not seeing the big eye.
Mhm. It's
Okay.
not getting the
So
routing.
maybe the proper routing was not in place,
Mhm.
right? So that was maybe the issue. We have to check that. But
Mhm.
we was not able to see the big eye.
Mhm.
So as soon as the packets checks the routing,
Mhm.
okay, you see the big eye. And
Mhm.
when we talk about the small eye,
Mhm.
it means the packet hits to your firewall. The
Mhm.
policy verification also done. As you can, as we saw yesterday,
Mhm.
that policy acceptance was there. Like we
Mhm.
were saying, okay, this packet is got accepted,
Mhm.
right? We were saying into the policy,
Mhm.
right? And we
Yeah.
also saying that sync flag. So this
Mhm.
I interception means your policy, your
Mhm.
firewall hit. Then
Okay.
big I means your routing.
Mhm.
Okay.
Mhm.
Now, once the routing is performed, the natting happens.
Mhm.
And once the natting happens, you will see oh. So actual natting will be happen here,
Before it exits out.
right?
Mhm.
So this question generally we get into the checkpoint questions,
Mhm.
CCSA, CCSE.
Mhm.
Also we get during the interview as well.
Where does the netting occur in the path?
Yeah, and what is the packet flow if we talk about,
Yeah.
say outbound packet.
Mhm.
So this is the outbound packet flow.
Yep.
Okay, clear so far?
It's clear. So what? Yeah, the first I is where the policy is checked, and it comes
Mm-hmm,
inside, and
mm-hmm,
what that is extra. And then once it's inside, it is where the routing is done, and
mm-hmm.
then once it goes from there, it goes to the small O. That's where the what does that do? But
Netting.
netting. It's okay. Oh, okay, that is the key part for netting. Okay,
Okay,
got it.
and then
Mm-hmm.
once the packet left your stack,
Uh huh.
TCP stack, your firewall,
Uh huh.
you will see the O,
This is a correct traffic flow.
right?
Yeah.
Now, how the original packet look once it get translated.
Uh huh.
So your source, say this firewall,
Yeah.
this IP address we have netted with 172.21.101.1.
Uh huh.
Okay, so your source will change
Mm-hmm.
to this because the netting.
Mm-hmm.
Your destination will be remain same because
Yeah,
you
it's
have
going to
switched
the
to
same.
start.
Yes.
Your destination port also remain the same.
Uh-huh.
But if you notice, this port is got changed.
Yeah, it's 12531 and the
Yeah.
IP. Yeah.
Yes. So this is the one way the
Uh-huh.
packet say we were accessing say yesterday www.checkpoint.com,
Mm-hmm.
right? So
Yep.
consider this checkpoint for IP address.
Mm-hmm.
So now the packet hit here.
Mm-hmm.
Okay. So this is my checkpoint web server.
Mm-hmm.
Now the response come back. Let's
Got
see
it.
how it.
Now the destination is the client.
So,
Yeah. May I see that difference? Yeah.
so this is my checkpoint web server.
Uh-huh.
So how the reply packet will be? So in reply packet,
Yeah.
your whatever the checkpoint site has the IP address,
Uh-huh.
that will become source
Uh-huh.
because we are coming from there, right?
Yep.
This is a reply packet. The
Mm-hmm.
port will be the same.
Mm-hmm.
And if you see the destination is 172.21.101, which is your private NAT IP, sorry, public NAT IP address.
Mm-hmm.
And if you see the port, I mean, how the communication is recognized. So once the conversation of this port happen with
Mm-hmm.
respect to the firewall, then it remains same. Okay.
Mm-hmm.
So because of that, the response reply happens. Otherwise, if again the port getting changed during the response packet, then
Mm-hmm.
this packet will lost, right?
Mm-hmm. Mm-hmm.
So now the port will be the same for what
Mm-hmm.
we have seen here, right?
Mm-hmm.
So if you see 1253,
Mm-hmm.
okay, is associated with 172.21.101, which was your public IP address.
Mm-hmm.
Now, in returning,
Mm-hmm.
same things happens.
Yeah, but it's a
Okay,
flip order.
only with the flip order.
Yeah.
So in returning, you are seeing small I, which
Policy.
means your policy of NAT
Yeah.
and the access policies that is
Oh,
got checked.
okay.
Once that is got checked, your NATing happens here. Sorry, routing
Oh,
happens
routing.
here,
Uh-huh.
and the packet now moving to the inside interface.
And put
And
it back to
here your
netting. Netting.
NATing happen, and then it will come to the inside interface, and you will see the big O.
Uh-huh.
And see, once it is inside interface, again the NAT, after the NAT conversion, you will
Yeah.
see the port change also.
Got it. Get back to routing.
Okay,
Yeah.
this is happens in a hide NAT, and when we create a policy for the hide NAT, generally two rules created. We have a automatic hide NAT process.
Uh-huh. Uh-huh.
So when we do that,
Mm-hmm.
two rules created.
Mm-hmm.
Okay, people thinks that the two rules is one rule for the this sending the packet
Mm-hmm.
and one rule is for the
Coming in.
coming in.
Yeah.
But actually, do you think it require two port the two rules?
No, because it's one table.
Yeah, right. So if you closely look into that rules,
Uh-huh.
you will see the first rule is for
Mm-hmm.
the packet or the whatever the IP address we are assigning
Mm-hmm.
original. Okay,
Mm-hmm.
those IP address should not change. Because of that, the first rule creates. So you
Okay.
will see your original packet and
Uh-huh.
the translated packet. You
Uh-huh.
will see on the rule your
Uh-huh.
source is this IP address 10.
Uh-huh.
Okay,
Uh-huh.
and in translated packet you also see the source same. Why this rule required? During this communication, your source IP address should not alter to something else.
Okay.
Okay,
Yeah.
in hide net only I'm talking about.
Okay.
And the second rule, it actually do the purpose. So in
Mm.
second rule, you will see your source IP address. So this
Mm-hmm.
is a source IP address.
Mm-hmm.
This is get hided behind the your public IP address, which was a
Okay.
172.
Uh-huh.
Okay.
Uh-huh.
So these two rules only talks about this thing.
Okay.
Okay? It's not talk about that the two rule needed for one for the
Uh-huh.
sending the packet and one for the replying the packet.
Uh-huh. Okay.
It out so far.
So that is the first rule. It is just one is the top one which does not change, and the one on the bottom
The first
is
rule only they create just to prevent their identity that whatever the originating,
yep,
okay,
yep.
should be like that only. It should not alter anywhere.
Mm-hmm.
Okay. And the second rule they create
Is the
for the
change.
purpose of hide net.
Got it.
Okay.
Got it.
And
Okay.
this is what the checkpoints arrangement. Okay.
Mm-hmm.
This applies not to the outside world technology, what we have, say, in a Cisco, in a FortiGate, in a Palo Alto. They
Mm-hmm.
have a different phenomena. Okay.
Mm-hmm. Mm-hmm.
Although hide net, what happens? Your internal IP address, they hide behind one IP address. That is happens. But
Mm-hmm.
everyone has a different phenomenon.
Mm-hmm.
Okay.
Mm-hmm.
This is what a checkpoint phenomenon.
Mm-hmm.
Okay.
Got it.
So when you compare this to the other firewall, you don't have to think on this perspective.
Mm-hmm.
Okay. They may be using some other technique.
Okay.
So keep in mind.
Yeah.
And we will witnessing that when we create a rule.
Okay. Got it. So this is
Okay.
HideNet.
This is hide net. Now let's see static net.
Okay.
So if you have understanding of the hide net,
Mm-hmm.
you'll be having an understanding on the static net.
Okay.
Okay.
Got it.
But some differences, I'll just tell you those.
Mm-hmm.
So in static net, in hide net, what mapping we have many to one,
Mm-hmm.
right?
Yep.
Many,
2-1.
uh,
Yeah.
let me change it. Uh, Many internals and
Mm-hmm.
one
I know.
the external, for example.
Mm-hmm.
But in static net, you have one to one mapping.
Mm-hmm.
So one IP,
Mm-hmm.
one IP. Okay,
Mm-hmm.
one to one mapping.
Mm-hmm.
And static NAT is used when you want to take access out of your network. So this is your network. For example, this
Mm-hmm.
is your gateway, and you have this your network.
Mm-hmm.
Okay, and here you are sitting. This is my your PC.
Mm-hmm.
If you want to take access of this machine,
Mm-hmm.
okay, that time
Mm-hmm.
I will request this admin. Okay, I want to have the access of this machine. Can you create a static net for me? Okay.
Mm-hmm. Mm-hmm.
So what will happen here? You'll be having a one-to-one mapping
Mm-hmm.
where one IP address, which is
Mm-hmm.
external IP address, will map to the private IP address.
Mm-hmm.
Okay. So here we don't think more about the port change.
Mm-hmm.
If you see here in this diagram, we haven't specified anywhere about the port.
Mm-hmm.
Okay, because we don't care about the port, as
Mm-hmm.
we are statically giving something. That means the ports and everything we will be giving. For example, say this guy want a communication to this web server
Mm-hmm.
over a port, say 443,
Mm-hmm.
right? So
Mm-hmm.
we only allow that port
Got it.
like that.
Oh, got it. Got it.
So static NAT. Let's you got the basic fundamental behind the static NAT.
Yep, I got this. That it is 1-to-1, and the port stays the same on static. And
Yes. As a name suggests
yeah.
static, that means uh and as a name says dynamic, that is
Mm-hmm.
what. Okay.
Yeah, got it. I got it too.
So consider this is a machine
Mm-hmm.
from the external world,
Mm-hmm.
and he wanted to communicate to the machine which is in your network.
Mm-hmm.
Okay. This is your machine in the network, say web server,
Mm-hmm.
and this is your PC which is in the cloud or whatever it is,
Mm-hmm.
outside
Mm-hmm.
world. So how the
Mm-hmm.
packet will come? So this is the packets. For example, I have my Wi-Fi connected now, so
Mhm.
I'll be getting some IP address,
Mhm.
right? Likewise, you also get some IP address from your service provider. So
Mhm.
this is that IP address, for example, okay? And I want to reach to the internal server, this guy,
Mhm.
okay? But how this communication will happen, I have to hit to this public IP address.
Mhm.
What that means, when I define a static net rule, I have to do a static entries. For example, I will specify my rule like this. This is my original packet, and
Mhm.
this is my translator packet.
Mhm.
So I will give, okay, my source will be any, okay,
Mhm.
destination is my, say, this guy,
Mhm.
n.1, okay.
Mhm. Mhm.
Now, my destination
Mhm.
here
Mhm.
will be translated to 172,
Mhm.
for example, okay,
Mhm.
like that. So you have to give this into your uh, policy. That's why the static net happens.
Mhm.
Okay. So
Okay.
consider example like that.
Mhm.
The IP,
Mhm.
don't compare with the IPs what is here. I
Mhm.
just want to tell you like that static entry we need to define into the
Mhm.
NAT table. That's it. Okay.
Okay.
Let me clear up the screen. Okay. So how it works? So the source will hit to your public IP address, okay,
Mhm. Mhm.
which will define into our NAT policy,
Mhm.
okay.
Mhm.
So this will make it as a front IP address, and beneath this IP address, we'll have the private IP address, okay.
Mhm. Mhm.
So that conversion will happen, and you will get this access to this. So how the packet will come? Again, it will hit to your firewall,
Mhm.
okay. Then the policy get checked, NAT policy also get checked. So here two
Mhm.
policies checked. One
Mhm.
is your firewall explicit fire policy. So people generally forget to add the rule
Mhm.
when we talk about the static net. You
Mhm.
know,
Mhm.
we need to have explicit rule which allowing say any communication to your internal IP address.
Oh, we have to create a rule. If not, it's not. Even if there is netting set, it will not come in.
Right, it will not work. You need to
Oh,
have this rule. This is a star point.
that is
People do the
interesting.
netting and they ask, okay, check the things, and
Yeah.
it not works because they forget to do this rule.
Oh,
Why
and
we
you have to.
require this rule? Because we are coming out of the your network, right?
Yeah. Yeah.
If we are going inside from your network, okay, by
Okay.
default firewall will allow that because that is what the permitted. But
Yeah.
something is coming outside the network, how
Yeah.
firewall will allow that? You should
It
have
will.
a rule for that.
Everything is a drop rule, anyways.
Yeah, and it will hit to the drop tool and it will drop because
Yeah.
we will not find this
There's no
thing,
rule. Yeah.
right?
Makes so much sense.
So once that hit to I, the policy get checked, that explicit rule get checked, and
Makes sense. I see
yes,
why I is at the front because I is where the policy is checked, and
right,
that's makes so much sense.
right. And then the routing happens. In
Yep.
routing, it will convert to the external IP address to the internal IP address
Yep.
because you have to go from the external interface to the internal interface, right?
Yep.
And you know, here IP spoofing,
Mm-hmm.
anti-IP spoofing also plays a big role,
Mm.
right?
Mm.
So we have to do some configuration here as well in case the packet is getting dropped, you know.
Oh, yeah.
Right? So you have to think. Now you think you're thinking in a large picture
Correct.
why we
Correct.
learn the anti-spoofing and everything.
Yeah.
Because
Yeah.
now here the interface IP address is getting converted. I mean getting
Got it.
changed. You are going from external to the internal,
Yeah. Yeah.
right?
Yeah. Yeah.
For example, all other packets, say some malicious IP address is there,
Mm-hmm.
10.1 or something. Okay,
Mm-hmm.
he
Mm-hmm.
is trying to hit this guy. Okay, policy
Mm-hmm.
will say because you have given any, so one checks will be there.
Mm-hmm.
Okay, but you will be not
Mm-hmm.
having a netting in place. Okay, that's
Mm-hmm.
why if you don't have a netting for this conversation like that,
Mm-hmm.
then
Mm-hmm.
uh, the anti-spoofing will come into the picture. Provided
Makes sense.
yeah, these things. So, so for any question,
No, no, no. I'm understanding.
okay. Now, once that comes, the netting will happen here, and your
Mm-hmm.
packet will go to the outside, inside wall. Okay.
Mm-hmm. Mm-hmm.
Similar goes to the other direction. First,
Mm-hmm.
policy get checked.
Policy.
Okay.
Mm-hmm.
But when we talk about the policy get checked here, do you think which
Mm-hmm.
policy getting checked?
That's a good one. So the policy we'll check is going to be the
You know the answer.
policies that are going to check. It's going to be the first. Well, uh, it's going to be the policy set on the destination destination IP.
Okay. Do you think the policy get checked here?
It has to get checked, right?
Or state table will check?
Yes,
What will check?
it will check and see if something came in, if with this address, the
So
destination
basically,
address.
see, this entry is already recorded. This entry into
Yeah.
the state
Uh
table,
huh. Yeah.
right?
Yeah.
So returning packet
Uh huh.
will again not process all the policies.
Oh, okay. Okay.
It will check this state table. If this entry is already present, okay,
Then you. Uh huh.
it will go to the next level.
Oh, got it. Because there's already a record of it coming in.
Yeah.
Oh, got it.
But anyhow, you know, we have to see when you see this packet, this thing,
Uh huh.
uh, Wireshark output or that FW monitor output,
Mm-hmm.
you will see for one packet I, one packet big I,
Mm-hmm.
one packet small O, one packet big O.
Mm-hmm.
But do you see there multiple times this thing? You will see one time only.
Mm-hmm.
The reason behind it,
Mm-hmm.
one time only all checks happens.
Mm-hmm.
Okay. After that, your state table plays the role.
Mm-hmm.
But for the purpose of your understanding,
Mm-hmm.
this is how it, you know, things happens.
Okay.
I think I made you confused.
No, no, no. Of course, I understand now because once it comes inside, gets recorded in the state table. So once it's in the state table, it knows that, oh, okay, I did let a traffic come inside. So when the traffic goes out, it already just checked, oh, okay, there was a record in the state table for inbound, so it can go outbound.
Right.
Okay, got it.
So this is basic static
Mm-hmm,
and the hide NAT, and there
mm-hmm,
is one more NAT,
mm-hmm,
but that is not any separate entry.
mm-hmm,
It is just a combination. So they call it as a manual NAT.
mm-hmm,
Manual NAT, as a name suggests,
mm-hmm,
something you will, not use the feature of the static NAT
mm-hmm,
or not of the feature of the this dynamic NAT.
mm-hmm,
When I talk about the feature, I am talking about the automatic feature.
mm-hmm,
What this mean automatic? I will show you.
mm-hmm,
So when you open any firewall object or
mm-hmm,
any object, within this object, within a single click, you are able to create automatic NAT rules. Okay, you have to just specify what rule you needed. It is static or hide. Okay,
mm-hmm,
and accordingly, uh, in NAT policy, you will see two rules. Okay,
mm-hmm,
so this is easy method.
mm-hmm.
Okay, but in manual NAT, you will not use this, or you if you have some particular requirement and you don't want to use this
Mm-hmm.
feature which is automatically do the static and hide NAT,
Mm-hmm.
you do the manual NAT.
Mm.
So in manual net, you define, actually you create a role. In a explicit roles, how we create a role will give source IP, destination IP, source port, destination port, and allow and accept all those things.
Mhm.
Likewise, in manual net, you actual edit these tables. One is your original packet table,
Mhm.
and one is your translated packet table,
Mhm.
and you specifies, okay, what source the packet will come, what destination it will go, what services it will take, and in translation part, this source will translate to this which IP address, this destination will translate to which IP address, this services ports translated to this which IP address. Okay, I mean, in static NAT, you don't have much flexibility when we talk about automatic NAT. You
Mhm.
don't have much flexibility to, to alter the ports,
Mm.
right? Because
Okay.
I'll show you that
Mhm.
when you edit any object, okay,
Mhm.
by default, any comes. I mean, the services comes any,
Mhm.
something like that, okay?
Okay.
But if you have a specific requirement, okay, I want to, do the netting based on, say, this XYZ ports. For
Mhm.
example, I only wanted to, use this port to travel the traffic outside world and come inside world.
Mhm.
So in that sense, this manual net comes very handy. So
Mm.
here you will be having a flexibility to define your own ports, own uh, you know uh, details. Like in hide net or in a static net, not in a static net, but in a hide net, you see the ports are manually get selected by the firewall itself. Okay,
Mhm.
as we seen, one, two, three, four, whatever the ports was there, that source port, get
Mhm.
altered and changed.
Mhm.
But in manual NAT, it's in your hand, like which port you want to give. You know,
Mm.
over there,
Mhm.
the firewall will take that and go to the outside world like that.
Okay.
You know, so that
Mm.
is all about the manual NAT. Manually, entering those firewall rules,
Mhm.
netting rules, and based on that, do the configuration. Okay.
Got it. Got it.
So manual NAT will be clear more when we do the practicals on that,
Makes sense.
right?
That makes sense.
Uh, Let me check my notes.
Uh-huh.
What else is pending?
So that's three kinds of netting.
Yeah. Okay.
Static net.
So let's. I think let's you share your screen and we'll do the labs.